Dear students, welcome to this last minute revision video series of class 10th mathematics. Today we are going to start with this chapter, that is your first chapter, real numbers. In this video you are going to get the complete notes, or you can say the last minute revision notes of this chapter, real numbers, along with the most important examples of each and every topic and practice question sets, so that you can enhance your capabilities in solving the numericals of this real number chapters. And then at the end of these slides you are going to get the most prominent questions that are going to be asked, that are the most expected questions of your CBSE board examination, going to be held on 17th of February 2026. So let's begin with our chapter number 1. Say what are real numbers, what the topics which we need to study in this real numbers are. It initiates with the topic prime numbers, right? So I know everybody is aware of the topic prime numbers. What is a prime number? It is a number which is having only two factors, right? That is the 1 and the number itself. Okay, for example, these are the numbers 3, 11. These are the numbers which can be divided by 1 and the numbers themselves only. 2 is also a prime number, 7 is also a prime number. They are having the factors 1 and, say, 2 is having the factor 1 and 2 only, 7 is having the factor 1 and 7 only, right? So prime numbers are the numbers which are having factors 1 and the number itself, right? Next is what? Next is your composite numbers. So what are composite numbers? A number which is having more than two factors, right? A number which is having more than two factors. For example, these are the examples of composite numbers. We have infinite number of composite numbers. Some of the examples are written over here on this slide, right? Say 4 is a composite number, 6 is a composite number. It is having factors what? 1, 2, 3, 6 itself, right? 45 is a composite number. It is having factors what? That is 1, 5, okay, 9, 15 and so on. Like so, these all numbers are having factors which are more than 2 in number, so they are what? Composite numbers. These are the things which we have already studied in our earlier classes, so we need not to focus on them more, right? So say what is the next topic? That is your factor and factor tree, right? If a number divides another number exactly, it is called a factor. So what do you mean by a factor? The factor is nothing but a number. Say 2 is the number, it is the factor of 24. Why 2 is called the factor of 24? Because 2 divides the number 24 completely, right? It leaves no remainder when we divide 24 by 2. Likewise 3, 6, 12, they are all the factors of this 24. Even 24 itself is the factor of 24. 24 divides 24 completely, right? What do you mean by the prime factorization? So if we convert all the factors in terms of prime numbers, right, then the factorization of that particular number is known as what? Prime factorization. Here what you can see, that the factors which we have written for this 24 are all prime numbers. 2 is a prime number, 3 is a prime number, right? So this factorization of 24 is known as what? Prime factorization. Above is also a kind of factorization. Here we have written the factors of this, but we have not completely written this 24 in terms of product of any factors. So whenever you write a number in terms of product of prime numbers, right, so that thing is known as what? Prime factorization of that number, okay, right? So that is what this statement which you have given right now is nothing but your fundamental theorem of arithmetic. This statement is nothing but fundamental theorem of arithmetic. So what do we mean by fundamental theorem of arithmetic? Let's see. What is written over here is every composite number can be written as product of prime numbers, okay? So for example, we are having a composite number, say 36, okay? So 36 can be written as the product of prime numbers. How we can write? Say it can be written as 2 multiplied by 2 multiplied by 3 multiplied by 3, right? So 2 2 ja 4, 4 3 ja 12, 12 3 ja 36, right? So 36 can be written in terms of product of prime numbers like this. So every composite number, what this theorem says, every composite number, right, it can be written as the product of prime numbers, okay? See next, what do we mean by HCF and LCM, right? So what is HCF and what is LCM? See, what is HCF? It is the product of smallest power of common prime factors, right? It is the product of smallest power of common prime factors. On the next page we are going to see the examples as well. What is LCM? LCM is the product of greatest power of prime factors. So what are the examples? Say I am having two numbers, one is our 24, other number is 36, and we want to find HCF of them, right? We want to find HCF. So HCF is what? See what the definition says. It is the product of smallest power of the common prime factors. Okay, so look at the prime factors of these two numbers, and what is the smallest power of 2 in this common prime factors are 2 and 3, right? So what is the smallest power of 2 and 3 in the prime factorization of this? So see, smallest power of 2 is this 2 square. So we strike out what? 2 square multiplied by what is the smallest power of 3 in both these prime factorizations? 3 to the power 1. So this 3, so 2 square into 3, that means 4 into 3, that is equal to 12. So 12 is the HCF of this, right? So here what we have written 12. See what is LCM? LCM is nothing but the product of the greatest power of the prime factors. Okay, greatest power of the common prime factors. So greatest power of the prime factors. So see what are the prime factors over here? 2 and 3. Okay, so what is the greatest power of 2 in all this? That is 2 to the power 3. So to find LCM we will strike it out. 2 to the power 3 multiplied by what is the greatest power of 3 over here? 3 to the power 2. So we will write 3 to the power 2. So 2 to the power 3 is nothing but 8. 3 to the power is nothing but 9. 8 9 just 72. So 72 will be the LCM. So by this way you can find the HCF and LCM of two given numbers, right? So these are the basic definitions. So we need not to memorize the definitions. We need to know what method we have to follow or we have to use to find the HCF and LCM. So by using prime factors we can find the HCF and LCM of the numbers by this way. Okay, you have to memorize that. For HCF what you need to look at is the lowest powers. Okay, lowest powers of the common prime factors, right? Lowest powers. Okay, and for LCM you have to look at the highest powers. Okay, highest powers. Do not get confused in their name. Here HCF in HCF this H is highest, but we are looking at the lowest powers. Okay, but in LCM this is this L represents least, but we are looking for the highest powers. Okay, so you need not to confuse in the names and the methodology that we are adopting from the prime factors that we are using to find out the HCF and LCM of given numbers. Okay, so let's see what is the relationship between HCF and LCM. So for any two positive numbers, any two positive numbers A and B. Okay, so HCF, suppose we have find out the HCF, suppose we have find out the LCM, then product of HCF and LCM is nothing but the equal to the product of A and B. For example, let's take the previous two numbers. Here the numbers were what? 24 and 36. Okay, so 24 and 36 were the two numbers, and then we found out what? The HCF and LCM of these two numbers, right? So as per this statement, the HCF and LCM, product of HCF and LCM, so HCF was 12, LCM was 72, so 12 multiplied by 72, that will yield what? That will be equal to product of the numbers 24 and 36. 24 multiplied by 36. This you can cross check by multiplying these two numbers, that this product will be same. Okay, so this is very important result. So this result is very important, right? So this you need to memorize. This we are going to get a 1 mark or 2 mark question in your board examination on this particular concept, that is the relation between HCF and LCM. Okay, so these two relations which are written down over here, they are nothing but they have been extracted from this one only. Suppose we have to find HCF, that HCF is nothing but the product divided by LCM, and if we want to find LCM, that is nothing but the product divided by HCF. Okay, so let's move on to the next slide. Now real numbers classification. So real numbers can be broadly classified into two types. One is your rational numbers and one is what? Your irrational numbers. Okay, so what are rational and irrational numbers? So rational numbers, what is a rational number? A number which can be written in the form of P by Q. Okay, P upon Q, a number which we can write in the form of P upon Q, where what P is nothing but an integer. P should be an integer. What is Q? Q should also be an integer. And what one more important condition is what? That Q must not be equal to 0, as 0 is also an integer. The P in Q may be positive or negative, but Q must not be equal to 0. For examples, these are the examples. This minus 3, 0, 7, 11 divided by 2, minus 3 by 5, 4 by 7, they are all rational numbers because they all can be written in the form of P upon Q, and the denominator of every number is not equal to 0. 0 is also a rational number. Okay, we can write 0 upon 1 like this. So this is of the form P upon Q, and denominator is not equal to 0, right? So what are the this question is for you. Check whether 9 by 4 is rational or not. So yes, it is a rational number. Why? Because we can express it in the form of P upon Q, where both 9 and 4 are what? Integers, and the denominator is equal to 4. It is not 0, right? So this is nothing but a rational number, right? Now what we have to see, what is an irrational number. So irrational number is like this. Okay, here what? We cannot write them in the form of P upon Q, where P and Q have their usual meanings that we discussed in the rational numbers, right? P is an integer, Q is an integer, and Q must not be equal to 0. Okay, so irrational numbers are the numbers which do not follow this. Okay, they do not follow this. Okay, for example, square root of 2. The square root of 2 itself is not an integer. Okay, it is not an integer value. So if you write it square root of 2 by 1, so denominator is an integer, it is not equal to 0. You are fulfilling these two conditions. But again, this numerator is not an integer, it is the square root, it is having a decimal value, so it cannot be a rational number. Okay, so irrational numbers are nothing but the numbers which we cannot express, in the form of P upon Q. Okay, these are the examples. Root 2 is an irrational number, root 3 is an irrational number, this root 15, pi. Okay, see, for example, these are the example. Root 2 is an irrational number. This is a proof based question. We are going to deal it with later on in this slides. So this is an important question. I hope you all would have studied in your classes. Teachers used to take these examples whenever they used to teach you in the classroom. So since we are doing the last minute revision, so we will be focusing on only those questions which are very prominent to come in the board examination. This is also a prominent question. I will be solving this question later on in this slideshow, but right as of now you have to memorize that root 2 is an irrational number. Okay, next, integers. So integers are these numbers, you know very well, minus 2, minus 1, 0, the numbers which are not decimal numbers or some fractions. They are simply numbers, but they may be negative, 0 or positive, so they are the integers. Okay, what are the whole numbers? So whole numbers are the numbers which usually start from 0, and natural numbers start from 1. Okay, so these all definitions you have already studied in your earlier classes, right? See, these are some important results. This is a very important result. Sometimes they ask you in a 1 mark question. If P is a prime number. Okay, if P is a prime number, you need to memorize this. If P is a prime number, and if this prime number divides a number a square, okay, then P will divide a as well. Okay, so if P is a prime number and if it is dividing a number a square, then it will divide a as well. Okay, right? For example, say if P is equal to 2 and say a square is equal to 36, so if 2 divides 36, okay, obviously we know that 36 can be perfectly divided by 2, we will get the result 18. Okay, so if 2 divides 36, then 2 will also divide, square root of this. So square root of this is 6, so 6 will be divided by 2 as well. Okay, so this result is applicable to all the numbers in which you see that if a prime number divides the square of a number, then that prime number divides that number also. Okay, see, next, this is a very important result, right? What this statement says, see, if x and y are rational numbers, then x plus y by 2 is a rational number between them. Okay, if x and y are rational, see, you need to take care of the words written on this slide, है ना? If x and y are rational numbers, then what x plus y whole divided by 2 represents? It represents a rational number between them. For example, suppose I am having two numbers, say I am having a number x equal to say 4 and I am having a number y equal to say 6. So what if x is a rational number, y is a rational number, then x plus y divided by 2. So what will be x plus y divided by 2 will be nothing but 4 plus 6 divided by 2, that is 10 divided by 2, that is 5. So 5 is a number in between them, है ना? 5 is a number between x and y, obviously you can see. Suppose I am having two rational numbers like 3 and 9, okay, 3 and 9, okay. So 3 plus 9 by 2, so 3 plus 9 divided by 2, that is 12 by 2, so that is 6. So 6 is a number that comes in between 3 and 9 somewhere, okay. So this you need to memorize, okay. These results actually we are going to use in algebra type topics. So these are all taught in real numbers. I know questions are not being asked on these topics, but since we are doing last minute revision, so we must revise each and every topic whichever is written in your NCERT. We must not leave any single statement over there so that it gets unprepared, okay. So between two irrational numbers, what happens? See, if x and y are distinct irrational numbers, suppose we are having two distinct irrational numbers. Distinct means they should be different, okay. If x and y are two different or two distinct irrational numbers, then square root of the product of x and y is an irrational number between them. For example, suppose I am having a irrational number x is equal to root 2 and y is equal to root 3. Suppose I am having two numbers x and y equal to root 2 and root 3 respectively. Then if somebody asks you to find an irrational number between them, okay, find an irrational number between these root 2 and root 3. So irrational number between root 3 and root 3 will be nothing but the square root of product of x and y. So that will be nothing but root 2 multiplied by root 3 to the power 1 by 2, or the square root of this product, okay. So square root of this product will give you an irrational number which is in between these x and y, okay. See what is next, some operations on irrational numbers, okay. See, addition and subtraction of two irrational numbers, that is usually irrational, that is always irrational, but we are having an exception over here. Suppose the two irrational numbers are not distinct, okay. Suppose they are not distinct, they are common, say 1 root 2, both are root 2. So root 2 minus root 2 gives you 0, but 0 is a rational number, okay. So this is one exception in this addition subtraction rule, okay. But apart from this exception, what we can say, that addition of two irrational numbers or subtraction of two irrational numbers, that will always give you an irrational number, okay. So this you have to memorize. Next it was product. Say I am having an irrational number, and if I am multiplying it with another irrational number, the product may be rational or irrational. So this is a very important result, okay. Suppose I am having an irrational number and I am multiplying it with an irrational number, so product may be rational or irrational. It depends upon the irrational numbers which you are going to do the product, okay. But on the same side, the product of two rational numbers is always a rational number. So these two results are very important. These are very important results. We use these results in proving a given algebraic value, whether it is a rational or irrational number. So these two results are very important. You need to memorize them, that product of two irrational numbers, it may be rational or irrational, it depends, but product of two rational numbers is always rational, okay. See, for example, say I am having this product of root 3 and root 5. So product of root 3 and root 5, root 3 is an irrational number, root 5 is an irrational number, the product will give you root 15, that is also an irrational number. But on the same side, if I am having number root 5 multiplied by root 5, so that will give you 5, which is a rational number. So product of two irrational numbers may be rational or it may be irrational. It depends what values you are taking as irrational numbers. Okay, these are the examples. Say I am having two irrational numbers, one is root 2, another one is root 2. Root 2 multiplied by root 2 will give you 2, that is a rational number. Suppose I am having an irrational number root 2, I am adding with it another irrational number root 3, so addition will always be an irrational number. This is important. Suppose I am having a rational number 3 upon 4, another rational number 5 upon 6. I am doing the product of these numbers, the result will be a rational number always. Okay, so these are some results or the examples which we must memorize. They are very important, right? There are some practice questions for you as well. You can practice them at your own. You have to find out the HCF and LCM of these two, so try to find out this HCF and LCM using prime factorization technique. Okay, you have to find whether 97 is a prime number or not. You need to classify these into rational and irrational. You have to find a rational number between these two. All we have discussed in the previous slides. Okay, so these were the topics that actually we have to study, we have to revise, we have to memorize in the first chapter of your class 10 mathematics, that is the real numbers. Okay, so we have covered each and every topic whatever is written in your NCERT. So we have not thoroughly revised each and everything, but yes, for the sake of last minute revision we have studied each and everything which is written over there in your NCERT. Now I am going to discuss with you the most expected questions in board examination, right? So the section which now we are going to discuss, that questions have been taken the pattern from the last 10 to 15 years. I have seen the pattern, observed and analyzed them, and then have taken out these questions, and they are supposed to be the most expected question this year. Okay, so this is the first question, right? Prove that 5 minus 2 root 3 is an irrational number. Okay, so you can come across such questions. They may be asked in a 3-mark question. Okay, you have to prove 5 minus 2 root 3 whether it is an irrational. You have to check whether it is an irrational number or you have to prove it. Okay, so we already know that subtraction of a rational minus irrational will give you an irrational number. So this is one proven result, but we need to prove it mathematically over here. So what we need to do is how you have to write your solution, that I am going to discuss over here. Okay, so initially let us assume that 5 minus 2 root 3 is a rational number. Say suppose it is a rational number. Okay, let us assume to be a rational number. Okay, so let this be a rational number. So I am writing it over here, how you have to write it in your board examination. So let 5 minus root 3 be a 2 root 3 be a rational number. So we can assume 5 minus 2 root 3, that is equal to P upon Q, where P and Q have their usual meanings. Matlab P is an integer, Q is also an integer, both must be co-prime, and Q must not be equal to 0. So from the above expression what we can write, that P minus P upon Q, that is equal to 2 divided by root 3, that we can write from here. What I did is I brought P upon Q from right to left hand side, and I sent this to root 3 to the right hand side of this expression. Now what we can write, that 5 upon 2 minus P upon 2Q, that is equal to root 3. I have divided the whole equation by 2. Okay, so now look at this expression. In the left hand side, this 5 upon 2 is a rational number, this P upon 2Q is of course a rational number, and as we know that this difference of two rational numbers always give a rational number. Okay, so this whole expression is nothing but a rational number, but on the right hand side what is written over here, root 3. So as per this equation, this root 3 must be a rational number, but this is contradictory, as we all know that root 3 is not a rational number. So what you have to write, but root 3 is a rational number. So since this is contradicting the fact that root 3 is an irrational number, that means our assumption that 5 minus root 3 to root 3 is rational number is false. So what it shows that our assumption is false. So that means it proves that what, this 5 minus 2 root 3 is nothing but an irrational number. Okay, so this is the way how you have to prove. So you can do many questions which are asked in this particular format like this. Okay, you need to first assume that given irrational number in terms of a rational number like p by q, and then you need to do something like this. Okay, and after that you will come to prove that our assumption is false and the given number is nothing but an irrational number. So this is a very prominent question in board examination 2026. This you're definitely going to get in a 2 mark or 3 mark. Okay, so let's move to the next question. Prove that root 2 is irrational. This question has been asked many times in previous year board examinations. In the last 10 to 15 years examination question papers have gone through this question around 7 to 8 times. So this gives very importance, this is a very important question. So let's move on to the solution of this question as well. Okay, so let us initially assume that root 2 is a rational number. Okay, so let root 2 be a rational number. Okay, let root 2 be a rational number. So obviously we can write root 2 is equal to what, a upon b. Again, this a is an integer, b is also an integer, b must not be equal to 0. We should write it over here, b must not be equal to 0. One more thing which we must mention over here, that a and b must be co-prime. They must not have common factors except 1 in between them. Okay, so a and b must be co-prime, that then only this a upon b is a rational number. So suppose root 2 is a rational number. Okay, then what we can write, squaring both sides. If we square both sides, okay, suppose if we square both sides, so what you are going to get, 2 is equal to what, a square by b square, or we can write what, 2b square is equal to a square, or we can write what, b square is equal to a square divided by 2. So suppose if now we need to memorize those results that we had studied in the previous slides. Suppose if 2 divides a square, then 2 will divide a as well. This result we had studied in 2-3 slides back, that if a prime number divides square of a number, then that prime number also divides that particular number. So if 2 divides a square, then 2 will always also divide a as well. So we can write a in the form of like 2m. We can write this a as a product of 2 along with some number, say m. So let a equal to 2m. Now replace this a equal to 2m in this particular expression. So we can write b square is equal to 2m square by 2, or we can write what, it is equal to 4m square by 2, or that is equal to m square by 2. Okay, this we can write not this is 2m square. Okay, sorry, this is 2m square. So what we can write is m square is equal to what, b square divided by 2. Again what we should write, if 2 divides b square, then 2 must divide what, b. 2 must divide what, b also. Okay, so if 2 divides b square, it must divide b also. So what we can see from these two statements, this statement and this statement, that this 2 is a common factor of a and b. This 2 is nothing but the common factor of a and b. But what we have written over here, that for root 2 be a rational number of the form a upon b, this a and b, these two numbers must be what? Co-prime. They must not have a common factor in between them other than 1. But here what we can see, that 2 is a common factor between a and b. So this contradicts our assumption that root 2 is an irrational number. So you need to write that line over here. So this contradicts our assumption. So what? Root 2 is nothing but irrational. So this is a very important question. It is usually asked in 2 marks or 3 marks. This is very important question. Okay, so you need to memorize this question as well. Right, so let us move on to the next most prominent question of your 2026 examination. This is the question. This question has also been asked many times in previous year board examination. So there are many chances that this question is going to come in your examination as well. Okay, two positive integers. Look at the question first. Two positive integers a and b can be written as what they have written. A is equal to x cube y square and b equal to xy cube if x and y are the prime numbers. So you need to take care of this word, prime numbers. If x, that means what this is given, that is the prime factorization of a. Okay, what this is given, this is the prime factorization of b. So what is given? X cube multiplied by y cube, y square, and b is given x multiplied by y cube. Okay, find the LCM of a and b. So what I told you during the last minute revision slides, that to find out the lowest common multiple you have to look at the highest power. Okay, highest power. See, so what is the highest power of x over here in all these expressions? That is x cube. So strike out this x cube. And what is the highest power of y in this? So that is the y cube. So strike out this y cube. So LCM is nothing but the product of these two, x cube and y cube. So this is the result that we had studied in the revision slides of that particular statement. Okay, so you need to apply these statements in such questions. Okay, so LCM will be x cube and y cube. Suppose if it asks you what will be the HCF, so what will be the HCF? The lowest power of the common factors. So what is the lowest power of x over here? X. And what is the lowest power of y over here? That is y square. So xy square will be the HCF of these particular two given numbers a and b. Okay, so these are the three most prominent questions which you are going to it is expected that one of these questions may be asked in your 2026 papers. So I hope you would have got the last minute revision of this real numbers chapter. We will be posting the videos of the next chapters consequently. So all the best, revise from your textbooks, read all the questions of NCERT. I wish you very best of luck. Goodbye and take care. Okay.